Alright, in this next video in section 11.2 we're going to look at question number 3, and this question says the area of a triangle is given by the formula area equals 1/2 base times height. If we hold the base of the triangle constant, how are the height and the area related? What is the constant of variation? If we increase the height by 35%, by what percentage does the area change? Okay, so I've just abbreviated this formula here as A equals 1/2 base times height. And here's a picture here of a triangle with the base and height labeled, okay? And here's the assumption we're making, right? This base is assumed to be fixed, right? It says if we hold the base of the triangle constant. So this part is a constant. It can't change. But what can change is the height, okay? And if I change the height, that in turn will change the area, okay? So here's another triangle where I've kept the base fixed, the height's just gotten a little bit larger. Here's yet another triangle, again, same base, the height's just getting larger, right? As I do that, I can see that, well, the area is getting larger, right? So let's go ahead and make a note of that over here. We can say, okay, as the height increases, the area is going to increase as well, right? Which, if in the very first video in section 11.2, we talked about direct variation, and there we noted that if y and x varied directly, as x increased, y increased as well, right? So is this direct variation? Well, to answer that, let's look at the ratio of the area to the height. So a divided by h, what's that going to be? Well, here I'm just dividing the h over, so that's going to leave me with 1/2 times the base on the right hand side. And since the base is constant, say 10 centimeters, then 1/2 the base is also going to be constant, say 5 centimeters, right? So this part is in fact a constant value. It's not going to change. So what we've just shown here, right, is that the ratio of the area A and the height h is constant. And so because of this, right, A and h will vary directly. So we can say, so they vary directly. All right. Now the next part of the question says, what's the constant of variation? Okay, so this right here is a reference to what I called the constant of proportionality in another video. It's just, this is the K thing, right? In the definition of direct variation, we said that, well, y divided by x came out to be K, a constant. Well, that's exactly what we have here. A divided by h is this particular constant, 1/2 the base. So really we're just saying that the K in this instance is just 1/2 of this fixed B value, the fixed base value, right? Alright, great. Now the last part says if we increase the height by 35%, by what percentage does the area change? Okay, so I'm going to go ahead and go back to this relationship that we just wrote down. We know that the ratio of the area to the height is equal to this constant value. And the key thing, again, to just really take out of this is that this right-hand side cannot change, right? A can change and H can change, but this thing here is constant. Okay, so what am I going to do to H? I'm going to increase it by 35%. Okay, now what does that mean? Well, it means I'm going to take 100% of H, and then I'm going to tack on an extra 35% of H. So all in all, I'm going to have 135% of H. Now, 135%, that's 1.35. And this of h is really just indicating, okay, I'm going to multiply the height by 1.35, okay? So here's the deal. Going back to this equation, if I want to increase my original height by 35%, I'm going to accomplish that by multiplying the height by 1.35. But since this right side, right, this is fixed, it can't change, right? I then have to do what? Well, I have to counteract, right? The area will have to increase as well in really exactly the same fashion, so these 1.35s will wind up canceling out. So really, what has happened to A from this change in the height? The punchline is that if you increase the height by 35%, since the area and the height vary directly, then A, the area, will also increase by 35%. Okay? All right. Well, that is going to do it for this video. I'll see you next time.